NEC section 215.4 addresses feeders with a common neutral. The code allows 2 or 3 sets of 3-wire feeders, or 2 sets of 4-wire or 5-wire feeders to utilize a common neutral conductor. This means that multiple feeder circuits can share a single neutral conductor, provided specific conditions are met. This allowance is intended to reduce the amount of materials required in an installation, while still maintaining a safe and functional electrical system. To clarify, a 3-wire feeder typically consists of 2 ungrounded conductors, often referred to as hot wires, and a neutral conductor. A 4-wire feeder usually includes 3 ungrounded conductors, a neutral conductor, and often a grounding conductor. A 5-wire feeder would include 3 ungrounded conductors, a neutral conductor, and a separate equipment grounding conductor. The key is understanding the load balancing and harmonic considerations. When using a common neutral, the neutral conductor must be sized to carry the maximum possible unbalanced load. This is particularly important in systems with significant nonlinear loads, which can produce harmonic currents. Harmonic currents, especially the third harmonic and its multiples, are additive in the neutral conductor in a 3-phase 4-wire system. This can result in a neutral current that exceeds the current in any of the phase conductors, potentially overloading the neutral conductor if it is not properly sized. Therefore, careful calculation of the expected neutral current is essential. When determining the neutral load, the NEC provides guidance. Generally, the neutral conductor must be sized to carry the maximum unbalanced load. For household ranges, ovens, and electric dryers, demand factors can be applied as outlined in NEC Article 220. These demand factors recognize that not all appliances will operate at their maximum rated load simultaneously. However, it is crucial to note that these demand factors may not be applicable in all situations, particularly where there are significant nonlinear loads or where the loads are expected to operate at or near their maximum capacity for extended periods. Now, let's consider the specific requirements for the common neutral conductor itself. The neutral conductor must have sufficient ampacity to carry the maximum calculated and balanced load. This ampacity must be equal to or greater than the calculated neutral load according to NEC 220.61. The common neutral must also be continuous and uninterrupted. It should not contain any switches, circuit breakers, or other devices that could interrupt its continuity. This is to ensure that the neutral path is always available to carry fault current and prevent voltage imbalances. The NEC also addresses the potential for voltage drop in feeder conductors, including the neutral. Excessive voltage drop can lead to inefficient operation of equipment and premature failure of electrical components. To minimize voltage drop, the feeder conductors, including the common neutral, must be sized appropriately. The NEC provides guidance on voltage drop calculations in Informational Note number 2 of Section 215.2. While not mandatory, these recommendations should be followed to ensure optimal system performance. When installing a common neutral system, proper labeling is essential. The feeder conductors and the common neutral conductor must be clearly identified to indicate that they are part of a shared neutral system. This helps prevent accidental disconnection of the neutral conductor, which could create a dangerous condition. For example, the neutral conductor could be labeled with a tag stating common neutral for feeders 1 and 2. This labeling should be durable and easily visible. The NEC also requires that the overcurrent protection devices for the feeder conductors be coordinated to prevent nuisance tripping. If one feeder circuit experiences a fault, the overcurrent protection device for that circuit should trip without interrupting the other feeder circuits that share the common neutral. This coordination is typically achieved through the use of properly sized circuit breakers or fuses with appropriate time current characteristics. Additionally, it's important to consider the grounding requirements for the feeder system. The equipment grounding conductor must be properly sized and installed to provide a low impedance path for fault current. This grounding conductor must be connected to the equipment grounding bus in the electrical panel and to any metal enclosures or equipment connected to the feeder circuits. The grounding conductor helps to ensure that fault current will flow back to the source, tripping the overcurrent protection device and clearing the fault. Let's discuss a scenario to illustrate the application of NEC section 215.4a. Suppose there are two separate buildings on a property, each requiring a 3-wire feeder for general lighting and receptacle loads. Instead of running two separate neutral conductors from the main electrical panel to each building, a single, larger neutral conductor can be installed to serve both feeders. This common neutral conductor must be sized to carry the maximum unbalanced load from both buildings. To calculate the required ampacity of the common neutral, the maximum possible current on each ungrounded conductor in each feeder must be determined. Then, the unbalanced load is calculated based on the difference between the current on the ungrounded conductors, and the neutral conductor must be sized to carry this maximum unbalanced current. If the buildings have significant nonlinear loads, such as electronic ballasts for fluorescent lighting or variable frequency drives for motors, the harmonic currents must also be taken into account when sizing the neutral conductor. Another consideration is the length of the feeder conductors. Longer feeder runs will result in greater voltage drop, so the conductor size must be increased accordingly to maintain acceptable voltage levels at the load. The NEC provides tables and formulas for calculating voltage drop based on conductor length, current, and conductor material. In addition to the technical requirements, it's also important to consider the practical aspects of installing a common neutral system. The neutral conductor must be properly supported and protected from physical damage. It should also be installed in a raceway or cable assembly that is suitable for the environment in which it is installed. Furthermore, the connections to the neutral conductor must be made using approved connectors and methods. The connectors must be properly tightened to ensure a secure and reliable connection. Loose connections can lead to overheating and potential fire hazards. It is also important to ensure that the neutral conductor is properly identified at all connection points. This helps to prevent accidental disconnection of the neutral conductor during maintenance or repairs. The neutral conductor should be marked with white or grey insulation or with white marking tape to clearly identify it as the neutral conductor. When working with electrical systems, safety is always the top priority. Before working on any electrical circuit, the power must be turned off at the source. The circuit should be tested with a voltage tester to verify that it is de-energized. Appropriate personal protective equipment, such as insulated gloves and safety glasses, should be worn at all times. Only qualified and experienced electricians should perform electrical work. Electrical work can be dangerous, and improper installation or maintenance can lead to serious injury or death. In summary, NEC Section 215.4 allows for the use of a common neutral conductor for multiple feeder circuits, provided that certain conditions are met. The neutral conductor must be properly sized to carry the maximum unbalanced load, it must be continuous and uninterrupted, and it must be properly grounded. The feeder conductors and the common neutral conductor must be clearly identified, and the overcurrent protection devices must be coordinated to prevent nuisance tripping. By following these requirements, it is possible to safely and effectively use a common neutral system to reduce material costs and simplify electrical installations. Always consult the latest edition of the NEC and local electrical codes for specific requirements and interpretations. Understanding and adhering to these codes is essential for ensuring the safety and reliability of electrical systems. Proper planning, careful installation, and thorough testing are all critical to the success of any electrical project. Furthermore, ongoing maintenance and inspection are necessary to ensure that the electrical system continues to operate safely and efficiently over time. The NEC is a comprehensive document that covers a wide range of electrical topics. It is important to stay up to date with the latest changes and revisions to the code. The NEC is updated every 3 years, and each new edition incorporates new technologies, best practices, and lessons learned from past experiences. By staying informed about the NEC, electricians and other electrical professionals can ensure that they are providing the safest and most reliable electrical services possible.